Thank you very much, Professor Rio Kohsaka. First, for the invitation to present something, to share something on this very relevant webinar. And special thanks as well to Dr. J. Quevedo, who is one of prolific researchers on mangroves. Very few researchers we have now on mangroves. So without in the interest of time, I'm going to talk about mangroves in blue-green shades. I'm Dixon Gevana, and I'm currently professor in the College of Forestry and Natural Resources, University of the Philippines Los Baños, and serving as a director of the training center there. And I teach basically courses related to social forestry, governance, and those that are related to climate change. In terms of my research specialization, I'm currently working on coastal forest governance and also the climate change mitigation part, particularly the role of mangroves blue carbon in fighting climate change. So I'll be talking of I'll be talking of four parts. The part one will be global urban environmental challenges. Then after that, the blue-green infrastructure concepts and initiatives. Then the part three, I'll be talking about the mangroves in BGI, particularly the concepts and some of the initiatives that we have so far. And of course, the very important part would be the challenges and opportunities of integrating mangroves in blue-green infrastructure. And we can't help but to somehow settle together, have a leveling up of what the scenarios and trends as far as the global environment or global picture of of what we have now. The population through time is still increasing. Forest cover, though we are doing a lot of planting, but looking at the results, the net comparison would be we'll still have a decreasing forest cover, increasing greenhouse gases, then increasing global temperature. And of course, the demand for agriculture is still increasing, the energy as well, and for settlement. And these are all connected with, it's not really an oversimplification, but too much population or increasing population is basically the foundational, cause of all these, or foundational drivers of all these global environmental changes. And even the 1968, classic article of Garrett Hardin about the tragedy of the commons. And this is very much analogous to global population because we, right now we're seeing a lot of tipping points on climate, on many of our resources. And by 2050, we're expecting near about 10 billion people in the planet, which means more or intimate dependency or higher dependency on our natural resources. Hence, if we, surpass those tipping points, we have a degraded planet by that time. That's why the Stockholm Resilience Institute published this particular, very catchy and easy to understand, framework, measuring how much, we have exceeded the tipping points. Then, hence they call it planetary boundaries. And in many cases, we have already reached the high risk, the genetic diversity, even the pollution related to the voluminous amount of emissions in terms of phosphorus and nitrogen. And of course, climate change is already there at the yellow one is the increasing risk already. And some of the facts as well, this particular study by El Hakam published in Nature, way back, this just recently, 2020, global human man-made mass exceed all living biomass. So we have exceeded the capacity of forests or nature to produce its biomass. If we look at our man-made products like metals, asphalt, bricks, we have exceeded that. And one very scary statistic as well: 300 million plastic waste being produced annually, and only 8.3% are being recycled. So imagine too much waste. And of course, we cannot deny the natural disasters that we are having nowadays are increasingly linked to climate change. And that is also very true. That's why we keep on monitoring and also trying to solve this very complicated problem of increasing greenhouse gases. And first time in history, we have reached 400 ppm. And that is something that is very scary. And the future as well, based on so many projections, we are already, near the tipping point of 1.5 and 2 degrees Celsius. That's why we are seeing many, how to say that, detrimental or negative impacts of this changed climate in the near future. And of course, the meat of the topic today is the urbanization, and how we are going to balance everything, no, in terms of the development, now introducing green technologies. And this word cloud basically shows how biased the concept of urbanization in according to the public is, no. When talk about urbanization, it's really all about concrete, architecture, skyscraper. None mentioned here about about gardens or anything, no. So that is very true. That's why when we talk about urbanization, we are faced with a lot of problems. Number one, of course, on top is the solid waste, no? Like on that photo, air pollution is becoming more severe and difficult to solve in major cities, particularly in Asia. Like in this picture, I think this is Beijing or Shanghai. And also heat islands. It's also becoming more popular problem or being talked about because too much concrete, and then absorption of heat. And just for comparison, if you look at this, this figure on the left, rural areas, it's relatively colder as compared, of course, with the downtown or the urbanized area. And if you look at the park, it's way better in terms of the temperature. Okay, and then with climate change, we are also faced with drought, water stress, like in this photo in Manila, water rationing during El Nino or prolonged El Nino or drought, summer times. This is being done, no, even fire trucks has to go there and to provide them water, no. And also water pollution, hydrocarbons or effluents coming from industries, pharmaceuticals, and many others, polluting our bodies of water. Flooding, of course, I believe it will be mentioned several times in this webinar. And urban flooding or city flooding is becoming more problematic and severe. And right now, there are also some evidences that flooding problem is coupled by ground subsidence, like the elevation or the level of the land is decreasing, and it's because mainly of too much water, fresh water abstraction. That's why this is a very not very good mix. That's why if you have flooding and sea level rise and ground subsidence, will be expecting as wider areas covered with floods during monsoon period. And these are some of the projections and scary projections actually, like new elevation data triple estimates of global vulnerability to sea level rise and coastal flooding. Under high emissions, 630 million live on land below projected annual flood levels for 2100. But actually, we don't have to wait for 2100. Business as usual. If climate change will persist on a very fast rate, and this will be like a picture of Manila by 2050. And we have a lot of our major cities, are really located along coastal areas. And Manila would be like this, submerged, no? Many parts. So what else? Newman and co-authors, they published this particular, low elevation coastal zone population that will be, vulnerable or exposed to floods. And that projection is 2030 and 2060. It says here that the global LECZ or low elevation coastal zone population could rise by more than 50%. That's by between 2000 and 2030, and by 2060, more than a billion of people worldwide could be living, underwater. And top of the countries that will be there, very much submerged would be in Asia: China, India, Bangladesh, Indonesia, and Vietnam. And yeah, it's already happening, no? Like for example, in this photo, in Yoso City, Japan, no? And it is becoming more, how to say that, common, no? Like every year in the headlines, in the news, we would, see pictures like this. And of course, in Manila, Philippines, is like this. This is, these are jeepneys. These are our major, I main public transport, no? So they look like boats, no, with this very high flood, no? And what's the usual response to sea level rise or storm surge or perhaps tsunami? No, we see a lot of this massive seawall. And of course, one comment, direct comment would be, no, this is too much gray. And like this one in Jakarta as well, instead of, seawall was the immediate solution for the storm surge, but it also traps the flood coming from, the upstream and basically drowning the houses. And flood walls everywhere, like for example in this particular river, uh, well, this one in Las Piñas City is connected with a very, very, how to say that, healthy wetlands, but the upstream connection of the river is like this, covered with flood walls. And what ought to be done? Of course, many scientists, perhaps environmental champions are pushing this. We really need to pursue nature-based solutions, and there are, because of so many advantages. It's stable and it's the right way, to move forward, learning from the environment, capitalizing on nature. And of course, the eco DRR, ecosystem-based adaptation, as they're now, how to say that, the directions, no, or the principles to move forward because of many potential benefits aside from just one or a couple, like addressing floods or storm surge. You can get more benefits by bringing back or capitalizing on nature. And that is also true, no, in the recent COP26 in Glasgow. Of course, we know that by the mid-century, countries should be aiming, no, for net zero emission, and the world needs more green. So that's one of the major messages during that conference. And because nature, particularly forests, can act as carbon sink to capture and store atmospheric carbon. And the reality is still there. 20% of the carbon emission problem globally is because of mismanaged nature, particularly deforestation. And climate finance, there's a pledge to mobilize 100 billion a year to fund this action. And of course, any program, may it be nature-based solutions or the one we're talking about, the BGI, blue-green infrastructure, there's really a need, to have that consciousness on why we are doing this. Is basically, we are, hooking all of these efforts to meet, to realize these global targets. SDG on biodiversity, of course, we have Aichi target. We have several more for cultural and many others. All right. So I'm now moving to part 2 regarding the concepts and initiatives of BGI. And let me define first, just a very simple definition of green infrastructure. It's very easy to understand, I guess. It's all about green, network of parks, green spaces, green belts, garden, woodlands in the urban area. So this, doesn't include, of course, the rural area. So street trees and green roofs. And I like this place in the photo. One of my favorite place when I was in Korea, this Bungunsa Temple, is right at the front of it's really in the heart of a, how to say that, commercial center, that's Gangnam City. And it's in front of a very huge convention, and a mall, we call it COEX, they call it COEX. Another one is this one in Karatsu City in Saga Prefecture, Japan. They kept this Japanese black pine plantation, very huge, and that's how it looks like if you go on the ground. So these are some of the efforts on green engineer or green infrastructure. Blue infrastructure, on the other hand, water bodies such as pond, lakes, rivers, creeks, and mangroves. So basically, like for example, in this photo is the Kamogawa River in Kyoto, Japan, where flood waters run through this wide river. Now, blue-green infrastructure, of course, we'll be expecting more definitions later on as other speakers would deliver, no, or describe it. But here is an innovative approach that capitalizes on the benefit of harmonizing urban green spaces and natural water flow. Innovative in such a way there is no strict rule. Most of the time it's more on being creative, how to balance the green and the blue. Basically, plants and also natural, their role in natural water flow. And some of the definition I also got is network of natural and semi-natural landscape elements, which means there are still concrete that makes it semi-natural. So including of course the water bodies and green spaces with diverse environmental features, providing rich ecosystem services. And what's really the intention of BGI? It's really to minimize gray, because we have so much gray already that, the photos shown a while ago. That's the initial response and the usual response. It's really, in BGI, minimizing the gray barriers to allow land, plants, and water touch each other, like this particular photo. And there are also, of course, related concepts in BGI. One is a green-gray infrastructure, and it means like green infrastructure is very much related with BGI. When you apply green-gray infrastructure to mangroves, that can be BGI. That can be BGI. But alone, mangroves with some gray areas, that's green-gray. So integrating green infrastructure, forests, floodplains, wetlands, and soils, of course, that provides additional benefits. That's very important for improving the well-being. And of course, it's mixing it or harmonizing. I think that's the right word, harmonizing it with gray infrastructure like dam, seawall, roads, pipes of water, and treatment plants. So Conservation International is really pushing for this, advocacy of green-gray engineering or infrastructure. Another one that I found out is the sponge city. In many cities, only about 20 to 30% of rainwater seeps into the ground, and many of the storm waters or rainwaters are being disposed, or they go to elsewhere, and they're not being recycled or used for domestic water. Managing stormwater through increased infiltration, detention, storage, treatment, and drainage. And by implementing this, the impact of urban development on water-related problems can be diminished. So that's according to this source on the World Economic Forum, and according to Professor Yu. And then another one is, of course, the engineering side would be using semi-permeable materials, designing it like a terraces like this, so that it serves like a pond during the monsoon period. And during the dry period, it's like a park. So really multiple benefits, the multiple role. So why BGI? So that's a straightforward question with a straightforward answer as well. Just to make cities safe and more livable for all. Because with BGI, reduces the heat effect, stress, and noise, and increase or improves the natural ecosystem quality and biodiversity. And very important is the water. Sustainable water management provides as well cultural and recreational value and additional income for the local government, or city government, and also for some people. And like for example, in this one in the Dorimcion Promenade Park, somewhere around Silimro, is near the university where I had my grad study. So usually I pass this way, and then this is a very relaxing place, and during rainy season, it's like it's like a catchment. Okay, so mangrove forest in BGI, very important. Let's first briefly go over with the concepts of mangroves. When you say mangroves, it's a forest ecosystem that is situated or exclusive in the tropic and subtropic regions, and it's a land use also. We can call it a land use or a vegetation between terrestrial and marine communities. So they can only be found on those areas, coastal or riverine, and the plants there are, they are salt tolerant plants. Okay, so we call it halophytic plants. And these are some of the photos of a natural mangroves. Now, like here in the Philippines, we have many of these, or rhizopora dominated, mangrove forests. And like this one, this was planted by a local community there without any help from the government. They were able to establish this very huge, massive plantation of Rhizopora stylosa. Old growth, century-old mangroves of Palawan, no, it's a #1 tourist destination in the Philippines. So, they have this, unique mangrove forest, very old and big. Of course, in Bali, Indonesia, they were able to develop this mangrove forest into a eco park, no? Like on the photo, it's my first time to see this, pre-nuptial wedding photo in a mangrove site somewhere in Myanmar. Mangroves very important because they help to filter or prevent erosion from the upland. Like in this particular land use mix, right there on the upstream, they have rubber plantation. And then along the coastal downstream are mangroves. So there's a balanced way of how to say that managing, forest land use. And this is old growth mangroves, but very dwarf or scrubby. And this is in Del Carmen, Siargao. A very nice and pristine mangrove. And also one of the top tourist destination in the Philippines. So we have about 71 to 73 species of mangroves. Again, these are exclusive only on tropic and subtropic. And in the Philippines, we have 39 species. In Japan, is as much as 19 species, particularly in the southern part, Okinawa, Irimote Island. And why mangroves in BGI? Because, we have to know that everything is connected. And if we plant something upstream, there are always implication downstream. And mangroves, of course, they trap eroded sediments, and they also regulate, tidal waves, and minimizing coastal erosion, and they filter sediments, may it be with pollutants, before those sediments reach the coral reefs. No, so they also protect those that are actually on the sea, the seascape already. That's why I this is a very important how to say that remark. Mangroves link people, landscape, and seascape. And in Japan, the landscape management is if I'm not mistaken, is the Satoyama, and the seascape is Sato Umi. And in between are really very critical. They are mangroves, and they provide numerous ecosystem services and livelihood, coastal protection, water filtration, tourism, you name it. And of course, one of the highlight would be the climate regulation, because they store voluminous amount of carbon stack, way higher than the other forest ecosystem. And this particular study we had way back, I think this was 2015. We tried to account how much a hectare of mangroves worth. And through indirect benefits like fishing, recreation, roof thatch, material, fuel, wood, we got about $1,040 per hectare per year. And for carbon sequestration every year, we are expecting $110 per hectare per year. That's based on the 30 megagram carbon dioxide. And having those initial figures, mangrove worth $1,150 per hectare per year, and that doesn't actually include all other ecosystem services, like for example here, the protection against tsunami. Science is telling us that mangroves is very effective in protecting the coast from harsh tsunami or storm surge. In this study, the wider, the healthier the mangroves, the more effective the reduction of the wave force, and also the wave height. Significant, the taller the mangroves, the wider the mangrove forest, the greater the function of height reduction. And very important because of course water scarcity is a main problem in many urban areas, particularly in the coastal. The wider the mangroves, the mangrove cover, the lesser seawater intrusion based on many studies, particularly this one in Indonesia. That's on the adaptation side. On the mitigation, I mentioned a while ago on carbon sequestration. Blue, green infrastructure, mangroves plays itself very well because it's a blue ecosystem. It's one of the blue carbon ecosystem together with salt marsh, seagrass meadow, and mangrove. And of course, through the elementary science, we learned about photosynthesis. Mangroves store a lot of its sequesters voluminous amount of carbon stock into its biomass and sediment. And science is telling us that it's way larger, as compared with other tropical ecosystem. May it be like a dense plantation, they are no match with the capacity of mangrove. Mangroves is a powerhouse in carbon sequestration. Like keeping a hectare of mangrove trees would absorb or offset the emission of at least 7 buses that run throughout the year. So yeah, that's very true, and many studies confirm this. Like for example, the one in Sulawesi, Indonesia, almost 1,000 tons or megagram carbon per hectare was observed. And of course, this is the breakdown. And globally, we have 15.7 million hectares left. Philippines about 303,000, and Japan, not very small but healthy. I would guess it's 80% in Irimote Island of the 553 hectares. Why mangroves are cover is decreasing is because of many factors like this. Coastal development, reclamation, logging, agriculture. Number one is aquaculture, particularly in Asia. Conversion of mangroves, clearing of mangroves for fish ponds. And deforestation, of course, is very serious in Southeast Asia. We're losing about globally 21,000 hectares per year. And yeah, it's we also found in this particular a paper that we published 2.1% decrease between a decadal increase between 2000 to 2012 in Southeast Asia, and it's 46% anthropogenic, which means human driven. And well, looking at the urban area, the more injurious or significant threat to mangroves is of course the reclamation, particularly the unplanned reclamations. We have a lot of mangroves, natural mangroves, but they are being cleared for industries or for commercial infrastructures. And some how to say that some plants or some developments, they want to avoid mangroves, but indirectly they're causing also degradation to mangroves. Like for example, in this case, in this photo, sediment erosion is happening because of the too much pumping of the sand from that on the left side, that's the sea. So they pump it from the sea bottom and transfer it on the other side. But when we went on to the area to investigate, sediment erosion is already happening because of the too much pumping of the sand at the sea bottom. And this is the evidence of that mangroves are barely clinging on very few sediments. Their roots are very much exposed now. And we also noticed the urban mangrove forest fire. Forest fire is not possible in mangrove because it's always or almost every day underwater, but it became possible. What's the reason? It's because of too much waste that were trapped. These are solid waste, and during summer, dry season, you also have voluminous amounts of fuel now causing mangrove forest fire. And it's not natural, it's really anthropogenic. Okay, these are some of the snapshots of initiatives of integrating mangroves in BGI. I took this photo when I visited the Shenzhen Bay in China. It's very nice. It's like a garden, and they were able to develop this this park using mangroves. So mangroves right there near the sea, and then flowering gardens at the elevated portion of the park, and also in Pearl River Delta in China. It looks like this. They save some mangroves, and then they put up planting like an island, small pockets of mangroves along this big very busy river delta. Somewhere in Mumbai, India is also like this. But many of these, mangroves were not really an intentional BGI. No, they were not really saved for the sake of, this will be our BGI project, but accidentally, I would say, or incidentally, they are being left. Then if we're, if the government would like to pursue or capitalize on really, developing a BGI project over these areas where there are healthy mangroves left, then that's a good possibility. In Recife City, Brazil, if you look at these mangroves, is really within the very densely populated and very gray. That's how I describe this area. And this is how it looked like. No, very nice. Again, there's a balance, somehow a balance between green and gray here, uh, somewhere in Panama City. But it's quite difficult for us to know or to see which one is really the infrastructure, or if this is really, the BGA. That's why we have to look on a more, how to say that, a micro scale, like for example, this one. Now, this, I would believe this is a BGI because it's really a good mix of, mangroves there's a river there. And the purpose of mangroves is to retain the sediment so that it will also protect the grade. That's the semi-permeable, materials used for that, park. No, so this one's in Iloilo. This is in Iloilo, Philippines. It's the middle part or central part of the Philippines. And Abu Dhabi is planning for a mangrove city. So this is somehow very exciting because they're going to save this mangrove, and side by side with a commercial center, big buildings, and the mangrove will serve as like a park. And of course there will be some facilities there. And on the functions of the mangroves, of course, is on regulating tides and perhaps on water quality as well. This one in Sanya City, China, it won the Azure Magazine 2019 awards on landscape and architecture, and then they made use of mangroves. No, it's this is how it looks like, no, in the photo, according to that Azure Magazine award. So it's very nice, no? It's really finding the balance right there at the heart of the very busy and densely populated urban, or city. Mangroves exist. Now, the last part, challenges and opportunities, particularly in integrating mangroves in an urban setting, particularly in BGI. Now, challenge number one, perhaps I don't have the answers for all of these challenges, but maybe a discussion later, it will be, sufficiently, how to say that, tackled or discussed. Number one is demonstrate the cost-benefit advantage, gray versus BGI. And this particular study by Degnault and Gawit, published in Ecological Economics, dredging versus hedging, comparing hard infrastructure to ecosystem-based adaptations to flooding. So the highlights were actually this: we estimate cost and benefits options to mitigate flooding in Fiji, and ecosystem-based adaptation often yields higher net benefits than conventional options. And what else? Riparian buffers, most cost-effective with benefit-cost ratio between 2.8 and 21.6. And benefit increase by 100% or more when accounting for climate change. So it says here that, this is the right way forward. But, one would contest or some more argue, data and decisions or studies like these are apparently context-based. It works, or it's suitable for this particular case of or this site. But anyhow, BGI is always worth considering because it's not only this study who found out that by comparing the cost-benefit advantages of BGI is way better than gray, and there are many other studies as well. Hence, with those scientific evidences, it proves that BGI is worth pursuing. Number two is politics in urban planning. Now, in the case of the Philippines and many countries as well, I'm quite familiar with Southeast Asia, too many plans for a, even not only in the national government, but even in the local government. Too many plans. Sometimes those plans are overlapping, conflicting, and there's really, need to harmonize them. And a master plan could be a way forward, but sometimes it's difficult to do because particularly land use plan, because it will require, of course, capacities, competencies to pursue master plan. So many of the master plans, or uh, if either they are obsolete or irresponsive to what? To present and future needs and demands. When we factor in climate change in master plan, we would say that not all master plans that we have, particularly even, the rural or all cities, would be responsive to the, future projections of climate change. Challenge number 2, I think I have a couple of minutes left. Okay, challenge 2, politics and governance of urban development planning. Now, decision on land use planning and development, this is, usually the sad, story, mainly rests on people whose background are mainly on infrastructure development and less on environment, cultural, and other equally important aspects. So if we are, if our planners are really, biased always with the, infrastructure, it's really very difficult to push, BGI. And, what's the common reason? Perhaps more budget if you have great projects. So I put there a question mark. It could be always that way. More budget and, more funding, something like that, and beneficial for, for the company or the group who will be implementing the gray project. Convenience in the implementation and auditing, sometimes the auditing systems, you see, finding it difficult to audit, nature, like for example, nature services, and bring in, very important now to address this challenge is really to bring in ecologists, environmentalists in the planning team. Challenge number 3, and perhaps this is very important challenge, is to really, find the connectivity. Like we have to understand that although we are talking about the urban setting, of course, urban is always connected in other ecosystem, may it be rural. Particularly, I'm talking about, we have to put it on the platform or framework of watershed. Everything is connected by river, rivers connected to the lake and the sea. So that's why to integrate mangroves in BGI, we should not, or any BGI, per se, a plan, we should consider what would be the implications of the activities or the land uses coming from the other parts of the urban area or the rural areas where they are connected. So number 4, think globally and acting locally, making everyone understand and agree that there's a bigger picture. Why do we want to pursue BGI? We have to understand that there are really benefits, not only local, but global benefits. In this study that we had, a materialist and idealist divide, it's very simple that we ask the community, why are you, engaging or participating in government environmental projects? And then they said because of the income, they don't have that, realization yet that they can connect their efforts with the long-term tangible benefits as to human well-being that is beyond their community. Now, I mean, the positive impacts transcends beyond their community, but more on the global. So raising awareness is really important for buying in. People realize the benefits directly and indirectly by engaging. And this is basically one of the intentions of this collaborative project on socio-ecological production landscape and seascape, to find the connection of conservation, managing this landscape and seascape on improving the well-being, resiliency of the people, or should I say in the urban areas, pursuing BGI, and what would be, the tangible and intangible benefits, or what could contribute to the human well-being. Challenge number 5, addressing the foundational problems, because these have implications on sustainability of whatever infrastructure that we are putting in. If we have a lot of BGIs, but we still don't address urban sprawl, high urban or urban population growth, those BGI will surely give way to that expanding need for buildings, for spaces. as well as with increasing urban solid waste. No, if we have BGIs and still we cannot, address the sources of this waste, then they will get degraded. Water insecurity, poor water governance, climate change, like there's increasing demand for water. It could be a reason, and also the symptoms or the impact of unmanaged or poorly managed BGI. Challenge 6, almost few slides, I think. Growing mangroves in BGI is not easy because there's so many considerations. No, it's not just like planting and they will grow. What we are after is really the long-term survival of our green infrastructures, and right timing, right place, right nursery, right planting, and also right people. Like for right planting mangroves, we cannot just plant mangroves anywhere. We have to learn about the ecological preferences, and that's why we publish this article funded by APN, and people should be involved. Okay, few more. Opportunity. Now, after talking about the challenges, then the opportunities. Increasing financial support for nature-based climate solution, which actually BGI has a special place now. And of course, it's a major opportunity for many of the governments or private sector to pursue in collaborative manner. Okay, and there's a global EBA, no, ecosystem-based adaptation fund, and network on mangroves in BGIs, like for example, M4 cities. Maybe you're familiar with C40, no, the cities of 40. These are network or linkages of cities interested to the M40 is interested on helping each other to protect their mangroves and pursue BGI as well. Global Mangrove Alliance, of course, it's rallying a lot of stakeholders to increase the cover globally of mangroves by 20% by 2030. So finally, why mangroves again in BGI? BGI, blue-green infrastructure, will help save the remaining mangroves and secure enough space for them to grow, because it will be intentional when we have this BGI with plans, with the right space, the right location. We are providing them the opportunity to grow and expand, and also deliver their vital ecosystem services. City mangrove parks can also create new income sources like ecotourism, and very important is to raise again the environmental consciousness. In the first place, why do we need to mix blue, green with gray? So that's all. Thank you very much, and looking forward to our discussion later.
Thank you, Professor Dixon.